Before we can talk about lasers, though, we need to understand what stimulated emission is, since that's the key principle by which lasers work. And to understand this, we need to talk about what can happen in a molecule when we're looking at transitions between energy levels. So let's imagine a system where we have two energy levels. We have level 1, level 2. This is, whether rotational, electronic, vibrational, whatever. We're just considering two possible energy levels, and there's no other possible energy levels. So if we send in light that matches the difference in these energy levels, so delta E is the difference between E2 and E1, we want to send in light with a frequency of h nu that matches this energy level difference. So send in matching light. There are three possible outcomes that can happen. There's not three S's in the word possibilities. Three possibilities. So the first possibility is that the light is absorbed. So we imagine photon coming in, the light is absorbed, and we'll get our molecule, which we'll label M, will absorb the photon and become an excited molecule. So we'll indicate that by M star. All right, so this molecule starts in state 1, goes to state 2. So this is something like our dye experiment with a particle in a box, or any sort of UV vis absorption experiment that you've done before. So that's our first possibility. Our second possibility is known as spontaneous emission. This one actually doesn't require any light coming in. But if we have a molecule in the excited state, so M star, this is a molecule in state 2, it can spontaneously go down to the ground state, the lower state, state 1, and emit a photon that'll match the same frequency as the difference in energy levels. All right, so this is something like light bulbs operate on the principle of we excite a bunch of molecules using electricity, and sometime later the molecules will emit light. Often, billions of, nanoseconds later or something like that. So it usually doesn't take very long. But the rate at which this happens is, the rate of spontaneous emission. So, it just does it, at some given time after the molecule becomes excited. The third possibility, and both of these are not too weird, but the third possibility is what is known as stimulated emission. And this is kind of like the opposite of absorption. So with stimulated emission, we have a molecule that's in its excited state, so state 2. A photon comes along and causes emission of light. So the molecule goes down to state 1. So this is like spontaneous emission, but it's caused by, so it's emission caused by light. So just like the light can cause a transition from state 1 to state 2, it can also cause a transition from state 2 to state 1, and that's what stimulated emission is. So that's our third possibility. An example of this is laser light. So lasers operate on this principle that they cause stimulated emission, and we get amplification of the light, or the light becomes stronger because of that. So in the next video, we'll look at the rates at which these happen, which matter for being able to create a laser.